Morning everyone, here we are in sunny Sunbury. Massive big cloud came over, I thought it was going to get soaked. Anyway, this is how does the rotating laser compare with conventional automatic levels, which I showed you yesterday. I don't know if you can see this, but I've given station A, which was the one on the road, a height of 10 meters, added the back sight onto it, which we'd taken here as the middle reading, to give me a height of collimation 11.230. I've taken off the middle readings for the station C and D and got these at 9.942 and 10.192. I then took the three levels I took next to the poles, which was pole in the road, pole mid and pole by the trampoline, and these came out at 9.805, 9.805, 9.915, and then closing back on the foresight onto the station A was 10 meters with a foresight reading of 1.230. So now I'm going to use the laser to see how this compares with the three level points we took with the automatic level. And as I said to you before, there's three basic errors that you can get with leveling. One is writing it down wrong, which I took at the beginning, because these should have been reversed. I got my foresights and my back sights mixed up, mainly because a bit silly, but also under a bit of pressure and trying to remember everything to do here. But anyway, we sorted that out and we got 5mm error between the instrument's accuracy with this level, the staff's been as level as it could do. Obviously there's a couple of mil here and there, and there's a couple of mil in my reading on reading the actual height of the staff, which could contribute to that error. So anyway, so there's a booking error, one. There's the reading error, which is you're looking at the staff and getting it wrong. Then there's the instrument not being level, and that is that the compensator's not swinging, or there's obviously a fault in the level and it's not reading what it should be horizontally. And the last one is the staff is not vertical. It doesn't matter too much if it's a bit wonky this way, because you can interpolate with the centre cross errors, but certainly if it's held too far back by the guy holding it or too far forward, then you're going to get an error. And that's why I generally, if I haven't got a bubble, I'll get them to rotate the staff back and forward and always take the lowest reading. And again, either knock the side of the tripod, knock the side of the level, or spin the foot screw, and that'll make the compensator work. Some people tap the side of the tripod leg, but I don't think that's a good idea. And I would avoid tapping the instrument as well. It's best to use the foot screws, or if that other level I showed you, you've got a button on it, you push the button. So let's see how this laser compares to the conventional leveling. Right, this is you set this up, try and get the base of it as level as you can, and you just press it on and the whole thing self-levels within tolerance. And if it's out of level, it will show you a green light here, or a red light, and if the battery is getting stuffed, it will show you something there. So basically I've set it all up, I've put the reader onto the staff reading, and we'll go and see what that looks like to take the reading. So I'll take a back sight on there, I'll take a shot on the pole, shot on the station, shot on the other pole, shot on the other pole, shot on the station, and we'll see how these all work out with the reduced levels I've taken. Obviously if you were using this instead of conventional level, you would still take your back sights and foresights and make sure they're closed. So if I was going forward round the garden, I would take whatever levels I want here. Again, you need to set these out in a grid pattern by using the optical plummet, the optical square. and then set out your canes at 5 metre intervals, 10 metre intervals, 2 metre intervals, whatever you want. Then mark up these points and level them all. It doesn't give you any position, it only gives you the level with this one. So if I was going to change, I would change it a forward sight on there, move the laser to the next position, and then read the back sight onto this point here. Okay? So I'll go and see what this reads on here now. Right, so it's set on 1.202. I'll write that down. So back onto stationary, 1.202. My height of collimation will be that plus the 10 metres, which we said this was going to be the station height. So collimation height is a 11.202. Now if I adjust this, you get a big arrow and it tells me that it's too high, and if it goes down it tells me it's too low. So if I get it about right, that is it in there. I can switch off the beacon because I just, it just gives me the line and I know that's 1.202. So if I now move it to the other pole, we'll see how it fits out there. Tell me it. No, don't you dare. Right, battery went stuffed on this, changed it. But this is one of the things that happens with surveyors, is they go out in the field to do stuff and then your battery runs out. As prepared as you can be, you still get caught out. So I'll attach this on and continue levelling these 3 poles. Right, as you may have saw, the batteries did kick into play, and I thought it was good, but it obviously wasn't. So away again. Right. So whoops. So switch them on. See what the level is. Tell me to go up, not down. Right. There we are. So we're at a little bit up. Right, so that reads now 1.3. You just see the, I don't know if you can see it from there, but you just got the top bit of the block there, which is 8. So it's 1.389. 1.389. .389, and we'll go to station now and see what that's like. There we are, 1.2, and it's just over the top of there, so I'm going to put 1.251. 1.251. Right. Okay. Right, to the next point. Right, down here now. This is the mid pole. And that says 1.390. 1.390. Now that was the same as the first pole, if you remember. I don't know if you can, but I can. 1.390. 390. Right, and then we'll go to, you can see it flashing green still. We go to the other pole. Little green light flashing. It's 1.2, just in the bottom of the square there, 1.280. Oops. Go to the station and we'll read that, and then we'll go back to the start point. Here we are again. Flashing green at 1.001. 1.001 when it's up in level. 1.001. Right, that's the three of them done. Switch that off. Right, nothing done, so I'll reduce them now. As I said, the collimation height is 11.202. In fact, before I do that, I'm going to close it out like a good surveyor should, back on the station just to check. So that is 1.195. Now, it's all good stuff, me making mistakes, because it shows that we're not perfect. When I put the batteries back on, there is a little click, so when you push this up, you've got to put it up to the right stop, because if it's lower and the laser reading it, this part of it is not going to tell you what the staff reading is. So when I'd put down 1.202, it was actually 6-7 mil out, which is enough. So my collimation height and my initial back reading is wrong by 5 mil, so it's 1.195 and the collimation is 11.195. So if I now reduce the reduced levels from that, so one from that is, well, take that away, it's 10 meters, which is my height on station A. One from that's 4,499. And then we've got D is 4, 0 from that's 9, 0 from that's 1 from that's 10. Station pole number 1, 9 from that's 6, 9 from that's 0, 3 from that's 8, 2 from that's 9. Number 2 is 5, 9 from that 0, 3 from that 8, 2, 9, 0, 5, 8 from that, 1, 2 from that 9, 2 from that's 9, and then 10 meters closing out. So I don't know if you can see that now. So we got station C at 9942 conventional leveling and 9944, so 2 millimeters, which is pretty good. Station D, I had 10.192, and D on this is 194, so again 2 millimeters, very good. Pole number 1 was 9805, got 9806, 1 millimeter. Station 2, or pole 2, 805, 805 exact. Pole 3 next to the trampoline, 915, 915 exact. So it just proves that the spinning laser is comparable within a couple of mil to normal leveling procedures. I would hope that you'd be a bit tidier than I am with this. But as long as you know what you're doing and you're taking many shots, you've got what's called redundancy. You can throw half of them away, you still get the right answer, and that is the essence of the whole lot of it. So I hope it makes a bit of sense to you. Okay, go inside now, have a nice cup of coffee. Thank you for listening and watching. So this was an example on how rotating self-leveling laser compares to an accurate automatic level. And providing you do both with a reasonable amount of care and the environment that you're in, you should be able to get within a few millimetres of your intended levels. And as this is rough ground, I would say anything within 10 to 20 mil are fine. And it's probably worth notice, a surveyor like me, if he does it with an instrument with a prism in the top, he's going to walk back and forth because he's automatically, because the prism will get tracked with the instrument because it's infrared and it's got radio contact. You'll take the horizontal, well, you take the distance, slope distance, the vertical angle and the horizontal angle, and any code associated with that point will be automatically captured by the instrument. So I would grid this field just pacing 5 meters. I know exactly where the points are, but the detail pole will have a point on it so that we'll sit in the ground a little bit. So there might be sort of 5 or 10 mil different to using it with a normal level staff. But for this type of work it would be fine, because all you would do would contour this and then you would either scrape it out to make paved areas, raised planting, create a pond or whatever, so the whole landscape would change. But certainly if you level it properly, you don't want to be taking material away from site or bringing stuff in, so you would give it good level coverage, you contour it all, and then you can work out your quantities, your balance of your cut and fill. If you're going to build a pond, you cut out that material and you can build up raised beds or an embankment or a raised area, as there is over there. So time spent getting a good survey, getting a lot of detail. If you need that information later on to do any further design or any groundworks or engineering, then at least you've got the information, as opposed to going back to site and the site had all changed. Anyway, thank you for your time. My name's David Waterston, CD Surveys, and bye for now.